So here we are at gas practice part two, and we're starting off with the combined gas law. And again, you could set this up P1 V1 over T1 equals P2 V2 over T2, but eventually you have to cross multiply, and so that's the equation you see here. It's already cross multiplied out. And again, please don't forget to change your Celsius to Kelvin by adding 273. And so our first question here, we've got 3 liters of nitrous oxide stored at 293 Kelvin and a pressure of 1 atmosphere. So I see pressure, volume, and temperature. So that is my V1, my liters, T1 temperature, and P1 pressure. The gas is moved to a room with a new temperature, T2, and a new pressure, P2. What is the new volume going to be? So now I have to plug in either way. Again, you can have the proportion way or the cross multiplied, but eventually you get to this point. And so initial pressure, 1 atmosphere, times the 3 liters initial volume, times T2, 303 Kelvin. And my P2 is 2.5, V2 is what I'm looking for, 293 is my initial temperature, T1. And so I multiply on both sides. I have to divide by the 732.5 to solve for x, and that's how I get the 1.24 liters. 3 sig figs in every measurement, so 3 sig figs in my answer. Now, number 2 requires that I know the conditions for STP. I've got a gas at a volume of 4.6 liters, a temperature of 298 Kelvin, and a pressure of 96 kilopascals. What's the new volume of the gas going to be at STP? Knowing STP will tell you T2 and P2. So T2, since the standard temperature is 0 degrees Celsius, that of course is 273 Kelvin. P2, oh, it's right here. Okay, 273 Kelvin. P2 is 101.3 kilopascals. Yes, it's 1 atmosphere, but we've got to make sure we match our units. So since we have 96 kilopascals in the problem, I need to use the 101.3 kilopascals fact. So now I have my 5 numbers that I can plug in. I've got my P1, V1, T2, my 273. That equals P2, V2 times T1, the 298. Multiply both sides, divide by the 30,000 number to solve for x, and that's how I get the 4.0 liters. So again, knowing those STP conditions can help us to figure out 2 missing variables in the problem. Alright, next up we have the ideal gas law, and the ideal gas law is PV equals nRT. Alright, the other thing we do have to make sure that we remember is our volume must be in liters. That's in order for our constant to work. And you can see here, these are our values for R, depending on the pressure units. But our volume must be in liters. And so for this first problem, okay, you can see I gave you the volume of 750.5 milliliters. So you have to divide that by 1,000 to change it to liters. And of course, changing our Celsius to Kelvin. So now we have our information to plug in to our Pivnert equation. Pressure is what we're looking for. Our volume, once we divide it by 1,000, is 0.7505 liters. Moles, they give us in the problem 1.755. The R that I have to use is 8.314 because my pressure I'm trying to solve in kilopascals. And so that's why I have the 8.314. And then the temperature. Multiply both sides, divide. Make sure you divide by the right thing. I got to divide by 0.7505 in order to solve for x. And then with my sig figs, 6285 kilopascals. See if you can set up the next question where you're trying to solve for moles. Plug in the numbers in and solve for moles of oxygen. Pause the video, or if you've already done it, here we go. So we see that volume is in liters, 22.5, that's good. Pressure is in atmospheres, so since pressure is in atmospheres, I need to use this value of R, 0.0821. My temperature I had to change to 298.5 Kelvin, and I can multiply both sides, divide by the 24 part, so I can get to 1.12 moles. The second part says what's the mass of that oxygen gas. Well, of course, to get from moles to mass, I need to multiply by the periodic table. And so we have oxygen gas, which is O2, 16 plus 16, so that's 32 grams per mole. So when we multiply our moles times our molar mass, that's how I got the 35.8 grams of oxygen. Avogadro's law. Okay, again, map to moleville. And so we have liter land here with highway 22.4, and we can do all these problems using the map to moleville. So the first question, how many liters does that many moles of argon gas occupy? Well, if I know moles, I want to go to liters. I'm dividing by multiplying by 22.4. Do as you see, not as I say. And so that's how I got the 154 liters. Technically, I guess 154.0 if we're following our sig figs. Get it together, Mr. Sen. Next question. How many krypton molecules are in 75 liters of krypton gas? Sounds like we're going to particle town. Yay! So if I know my liters, now this time I have to divide by to get to moles, and then multiply by Avogadro to get to particle town. And that's exactly what I have to do. 75 divided by 22.4 times Avogadro, and that's how I get the 2.02 times 10 to the 24th molecules. Our third question here, what is the mass of that many liters of nitrogen dioxide gas? So again, we know our liters are up here. We need to divide by 22.4 to get to moles, and then multiply by the periodic table to get to mass. And so divide by 22.4, multiply by 46, because nitrogen is 14, and then there's 2 oxygens, so that adds up to 46, and that's how we get the 4,646 grams of nitrogen dioxide. Again, if you want to put any Avogadro examples on the back of your foldable, feel free to do so. Hope this helped out.